So the lab that we have, this is like a two-part lab. The first page is a lab that would have been done in the previous lesson, and it's about acids and bases. And I've
this is why you need a lesson plan.
Well, that wouldn't have helped me. I need to practice. Okay, so you would have done this lesson, the lab earlier. You guys can read through it real quick. You have to collect some materials, get into groups, and the lab is using indicator dyes. We've talked about indicator dyes, and we've also talked about acids and bases, and everybody should know by now the basics of acids and bases, and that when you're measuring pH in acids, you're measuring the concentration of hydronium ions, which are positive ions, and the concentration of hydroxide ions, which are negative ions. And so this lab is going to show how color indicator dyes can show you a little bit about, tell you a little bit about the concentration of a substance that you can't tell otherwise just by looking at it. So you've already done the lab, and you would have made a spreadsheet which says in the directions. And obviously, I can't ask you to whip up a spreadsheet. So this is the spreadsheet that you guys have all come up with. And so you got your 7 substances that you looked at. And these were your results. You used the red cabbage dye, which is one of the indicator dyes. And you used the phenolphthalein, which is another chemical indicator dye. And so who can tell me basically what a color indicator dye does and why we use them?
It tells us if something's an acid or a base.
And how does it do that?
It changes color, it reacts with that substance.
Right, it changes color. So it changes color because of
the different ions in there. If it's acidic or basic.
Right, because of the pH. These dyes it's the molecule takes on a different color depending on the pH that it's in. So if it's taking on a different color depending on the pH, who remembers what pH is a measure of actually? It's
potential for hydrogen?
Are you measuring a total amount of something? You're measuring
the concentration?
Right, the concentration. You're measuring the concentration of these ions. So it's kind of a multi-step process. The color of an indicator dye is telling you something about the substance. It's telling you the concentration of these ions. Okay, so in the beginning part of the lab, before you did any of the experiments, you were asked to kind of guess what you thought all of these substances would be, just based on your prior knowledge, if it would be an acid, a base, neutral. Do you guys remember doing that part? Does anybody, when you did the lab, did anybody have any surprises? Is there anything up here that surprised you as far as whether it was an acid or a base? You thought it was an acid, turned out to be base, anything like that?
Yeah, sometimes it was really hard to tell the different colors, like what was kind of purple and what was blue and then was going into red.
Right.
Sometimes it's really hard to tell.
So as I wrote this, I said you could write down what color you think you see. If it looks blue or green, write down blue-green, or green-yellow. So it can be kind of in between. It's not an exact quantitative experiment. So let's see. So okay, so you got your results. These are the results you got. Now let's go through the worksheet that I was asked to do afterwards. Let me look on yours here for a second. Oh no, I got my questions here. Okay, so and I give you. So I had you do this without any prior knowledge about how the dyes worked. And then on the second part here, I give you the, okay, I didn't write that, I should have written that up there. Can I borrow this? I give you the pHs of the red cabbage dye at certain pHs. Let me write that on there. Okay, so red cabbage dye at, if it's red, that's roughly 3.3 pH. Purple, 5.5 pH. Blue would be 7.0. Green would be 8.5. Yellow would be 11.5. Purple would be 5.5. Okay, in phenolphthalein, we have pink would be 8.2 up to about 12.0. Okay. Okay, so who can tell me what was the most acidic substance that they observed based on the colors that you had? So these are the
Drano.
pH numbers.
The Drano?
The most acidic, no,
The opposite, 3.2.
remember, we talked about this, the pH
Yep.
from 0 to 14, the acidic,
You have to teach the non-science people too. It's not
Oh.
even negative tutorial.
okay.
Vinegar?
The vinegar is the lowest pH. So the lowest number on the pH scale is the most acidic. Maybe I should have written the pH scale up here. pH, 0 to 14. Acid, base. They would have gotten this in the previous lesson, obviously.
Or is it obvious?
If they're a science student, they would have known that. Okay, so the vinegar was the most acidic. So if vinegar was the most acidic, what can somebody tell me about the hydrogen ion concentration of the vinegar? Was there a lot of hydrogen ion concentration or little hydrogen ion concentration?
High hydrogen.
Remember, high, right. So what we're measuring is ion concentration. So on this side, we have a greater concentration of hydrogen ions, and on this side, we have a higher concentration of hydroxide ions. So that's what we're measuring. That's what I'm trying to get you guys to understand, is that we're measuring the concentration of ions, okay? Okay. So what was the most basic ingredient here that you measured? Basic would be on the high side of the pH.
The Drano?
The Drano. Drano is really pretty high number, isn't it? So based on that number, what can you tell me about any ion concentration in the Drano?
There's a lot of hydroxide.
It's got a lot of hydroxide, exactly. A high concentration of hydroxide. It's all about concentration. Okay, I think you're starting to get this. And what about deionized water? Who wants to tell me something about deionized water?
Neutral.
It's neutral, which means what as far as concentration of ions?
It's not an acid, it's not a base. It's
Right, so the hydrogen ions and the hydroxide ions are equal, right, neutral, right in the middle, by definition. Deionized water, they do that in laboratories to get rid of the ions. Exactly, okay. So let's go to the last couple questions here. This will tell me if you have a very good grasp of this. So let's assume, who wants to read that question for me? Maybe that'll help. The second to last question. Renee, you want to read it?
This one right
The
here?
one about the vinegar.
Okay. If you were given a clear vinegar solution and you were told it contained pH indicator dye, what could you say about the dye? It would be
So
red. No?
Well, wait a minute. What are we giving in that question? The vinegar solution.
Mhm.
which is going to lead you to believe that it's what?
It's acidic,
Okay, what else does it say about the solution?
it's clear.
It's clear. Does it have any color in it?
No.
Okay, but it's got a dye. It didn't say which dye. So can you, just based on that, can you tell me anything about which dye it might have in it?
Oh, it's gotta have the pH dye, right?
Phenolphthalein. That's a big name. Phenolphthalein. Phenolphthalein. Okay, so that's clear under acidic conditions.
Okay.
Can anybody imagine why we would use a dye that's clear sometimes? I mean, red cabbage has all these nice colors. Carl, you have any idea?
Actually, Tom, I was busy making the video and showing you had 4 minutes left.
Oh, okay. Do you want to answer that question now?
I'm sorry, sir. I was not.
Oh, okay, that's fine. That's okay. We'll move on. So yes, the clear vinegar solution, if it's clear, it would have phenolphthalein in it, and not. There's red cabbage dye. There's chemicals in red cabbage dye that they could use for indicator dyes. There's lots of other indicator dyes too, for different pH areas. Let's look at that last question. You want to read the last question for me?
Right here, you have
Yeah.
2 test tubes with exactly 10 milliliters of different baking soda solution.
Two
You add
test-
2 drops of phenolphthalein
Phenolphthalein.
dye to each one, and they both turn pink.
Pink.
You now add HCl, hydrochloric acid,
Hydrochloric acid.
to each test tube, 1 drop at a time. The first test tube takes 20 drops of hydrochloric acid and then goes colorless. The second test tube takes 10 drops of hydrochloric acid and then goes colorless. Explain the pH of the starting solution and why they each took different amounts of hydrochloric acid to change color.
Okay, there's a couple of moving parts there. Does anybody want to start off? Anybody have any ideas where we're going with this? Baking soda solutions. What does that tell us? Baking soda solution.
Basic.
It's basic. Yeah, it might not be 8.5, it might be 9, it might be 7.5, but it's basic. So they're both basic. So now we neutralize it with hydrochloric acid. So if it's basic, it's got the hydroxide ion, right? So we add hydrochloric acid, which has, Katie?
Hydrogen.
The hydrogen ion. So we're going to neutralize the hydroxide until we get to a pH at which it's not pink anymore. If it's phenolphthalein, it will be, at what pH will this go colorless?
7. Oh, sorry.
About 8.2 is where it changes from pink to clear. Phenolphthalein is used a lot because it's one or the other. It's very drastic. As soon as you're going down in the scale, as soon as you get to 8.2 or below, it'll go from pink to 0. So we add the hydrochloric acid to both. And the first test tube takes 20 drops to neutralize. The second test tube takes 10 drops to neutralize. So can anybody tell me about what was the strength of the bases compared to each other based on how much acid it took to neutralize it?
Left was more basic.
The left is more basic because
There's more HCl.
it took more HCl, exactly. So if it took more HCl to neutralize it, there was more hydroxide to begin with, right? Okay, so we're measuring concentrations, and you can measure the concentration of something by how much of the opposite ion it takes to neutralize it. Okay, so that's the end of the lesson. Thank you.